When you write an assembly language program, it's one line at a time. Every line is a complete entity, and they have a definite syntax. The fundamental syntax of a line consists of 4 fields. A line can include all 4 of these or only one, but it's the basic form. A blank line is also valid. The assembler will just skip it. The same is true of any line that has a semicolon as its first non-blank character. A couple of things should be mentioned. Macros are different. The syntax is different. But when a macro is expanded, it produces lines of this form. Macros are covered in detail in a later lesson. The backslash character is a continuation character. If you put a backslash character at the end of a line, the next line is considered to be a continuation of the backslash line. The fields are separated by spaces and they must come in order, but it doesn't matter what column they start in. Also, the colon following the label is optional. This free form imposes some restrictions. For example, if you use a label that isn't followed by a colon, it cannot be one of the assembly language opcodes. But with a colon, the assembler can keep it straight. This may not be a good idea, but it is a valid statement, and this is not a valid statement, because here the assembler can't tell the label from an opcode. You can put a label on a line by itself with or without a colon. Both of these are valid statements as long as the label is not an opcode. As long as the label is not an opcode, the assembler can keep it straight. But there is another potential problem. This is a valid instruction for storing the contents of the AH register into the flags. It has no operands, and you can put it anywhere on the line, so if you misspell it, you get a label and you get no error message. The solution is to always use a colon and turn on the warning message that lets you know of labels on lines by themselves that don't have colons. The first character of a label can be a letter, an underscore, or a question mark. A label can also begin with a period, but the period has a special meaning, and I'll describe how that works later. A label can also be prepended by a $sign, which guarantees the assembler will read it as a symbol and not as a reserved word. The characters inside a label can be any combination of letters, numbers, underscores, dollars, hash marks, @ signs, tildes, periods, or question marks. And don't worry about the size. Each label can be up to 4,095 characters long, but they are case sensitive. These labels are not the same. It could be that you're using a linker on a system that is not case sensitive, but the symbols inside the assembler are. The opcode can be any machine instruction. It can also be preceded by a prefix of lock or of one of the repeat commands. I'll have more about those later. And it can be prefixed with size prefixes to include the instruction for one size inside an assembly which is otherwise for another size, 16, 32, or 64 bits. The operands you can use depend on the opcode. If there is more than one operand, they are separated by commas. An operand can be a register which is indicated by its name, or it can be a constant value. This is an example instruction that copies the number 17 into the EAX register. There are several ways of writing constants that's coming up. One type of operand that you'll use a lot is something called an effective address. An effective address is an address that is obtained by applying indexing or indirect addressing rules to a specified address. Brackets around an expression refer to the contents of an address. For example, this instruction will copy the contents of the memory location called blot into the AX register. Any index goes right in the brackets with it. For example, this instruction is the effective address 1 byte past blot. This effective address is the sum of the address of blot plus the amount in the CX register. Calculations with the index values to get effective addresses are quite common, and you'll see a lot of it going on in the examples for this course. You can put some fairly complex expressions in these brackets, but I tend to keep it simple. But you've got to know what those brackets do. Just remember, that these two instructions are completely different. The first one is a constant value of some type, or it's the address itself being copied into AX. The second one, the one with the brackets, is the contents of an effective address being copied.